Problem solving with quadratics. Some real-world problems can be solved using quadratic equations. Any answer we obtain must be checked to see if it's a reasonable answer. For example, we find a length that then has to be positive. If you get like -3 for a side, that doesn't make sense. If we're finding how many people are present, the answer must be a positive integer, but it can't be 2.5 or -6. When we solve problems, we generally follow this method of solving it. We read the question and try to make it into algebra, so we like retranslate into variables like x and such and make equations. We solve the equation using any method possible. So since we're doing quadratic, it's like factor, complete the square, or quadratic formula. Examine the solution carefully, see if they're acceptable. Make sure they're not like a decimal if we're talking about people. And then give your answers in a sentence. That's the general rule. So let's do an example real quick. The rectangle has a length of 3 centimeters longer than its width, and its area is 42. Find the width of the rectangle. So I read the question, and I'm going to draw a picture. I always like to draw pictures. Here's my rectangle. The length is 3 centimeters longer than its width. So what I always do is I make the smaller one x. So my width is smaller, it's x. The length is 3 centimeters longer, so x plus 3. So if I write that here, x and x plus 3. And the area equals 42. So you just got to figure out how to find the area. In this case, that's length times width. Right, so area equals length times width. Width times length. I know this is x, and this is x minus plus 3. And this is 42. So I was trying to draw it a little more proper here. Then we just try to solve it. X squared plus 3x equals 42. So from here we can solve it a couple different ways. So one way you could do it is by hand. You set equal to 0. And then either factor, use the quadratic formula. If it doesn't factor, and actually this does not factor nicely. Other one I'm showing you to do it using your calculator. Bring up mine. So here it is. So we're gonna go to y equals. And we're gonna do it, we'll do this one first. You actually do it both ways also. Let's type this in like this. So y1 was this, y2 was that. Typed in real quick. Then we're gonna hit graph. Now remember, we generally want to do zoom standard until we know better. And I get a graph that looks like this. And that's fine, that's all I need. Then it's in the graph. If you have a color calculator, graphs will show you 0. So I just want to figure out where these two guys intersect, here and here. So I'm press second calculator. 0 no, so we can also do 0 if we just want to solve for the zeros. But I did put 2 equations so I could go intersect, and it's a little bit easier. It's a little easier when you do 2 equations. So first curve, second curve. Remember the little trick, we press up, it goes to the other curve. So you just get close to that one. Enter. Now to get negative 8.1, but actually, we're talking about the width of a side, so that makes no sense. That was a waste of time. This is our only answer, right? We can't have x equal negative 8.15 be an answer. Doesn't fit in the domain. Go find the other x-intercept. And then here's a little trick if we're doing this by hand. Second and right makes it go a little faster. Now I'll do it on the calculator so it's just easy for me to hold it down. But second usually does a bigger skip. Let's get close to it. Hit enter a couple times. Oops, sorry. Second intersect. I had to do that first. Way back here. Right, so up. Go that way. And if you press second this way, it's a little faster. For me, I gotta scroll, so it's actually longer for me. With 2 fingers, it's faster. Hit enter. Enter. And I get 5.15. And that would be the answer. So that's one way to do it. Right, set equal to 0, y1, y2, graph it that way. You could also set graph it over here, y1, y2. If I go back to my equation here and delete this part of it and make this one 42, I could graph it. Now the one thing here is that I can change my window because this is all the way up to 42. So that means that there's a line up here at 42 I can't see right now. So in this case, I'm going to go to window, make my y max setting like 50. Right, so highest up goes on the y, so I won't be able to see it, so 42 right now, so I'm going to go higher than that, so about 50. Hit graph, and then there's x squared plus 3x, and there's 42. And then same idea, hit second calculate. I'm only going to find the positive one this time, because it's the only one that makes sense. Right, we're going to go all the way over there, I'm just going to keep it here. Get closer, press enter a couple times, and you get the exact same answer. Right, so 2 ways to solve it. Let's talk about the next one. The product of 2 consecutive even numbers is 360. So let's talk about how to do 2 consecutive even or odd. It's actually done the exact same way. That was a weird way to spell odd. you do x as the first consecutive even integer, and then x plus 2. Right? If you think about even numbers, they skip every 2 to get to the next one. Same thing with odd numbers. So even if it's at odd numbers, you do it the exact same way. So even odd, anytime they say that, consecutive even odd, you just do x and x plus 2 is 36. So the product, we're going to multiply these two guys. It's an equal 36. 360, sorry. 360. So again, I'm just going to solve from here, just like I showed you. So I'm going to go, okay, here's my thing. Here's y1, here's y2. I can do this by hand if I want to, set equal to 0. But we're just going to solve with our calculator. It's going to be a big part of today's lesson. So I'm going to go y equals, I'm going to type that in. X, because most of the time when you see this, so I'm just going to clear everything. On the IB exam, it's usually on the calculator portion. When it's doing it by hand, it's easy enough to factor. 360. Right, and then again, I gotta change my y max. This goes all the way to 360. So I'm gonna go to my window and get my y max. It's on like 400, so I can see it. So there's the graph. And if you notice, I can't see where it crosses. I need to go further out my left and my right. So I'm gonna change my x minute max. So I'm gonna go like, I don't know, negative 30, 30, so I can see it. So it looks like a good parabola. And there we go. Now in this case, let's make sure they're consecutive even numbers. Negative numbers are also even, so I actually got to find both answers in this case. So I can calculate. Intersect, I'm press 5 this time. Go close to this answer. See what it gives me. I get negative 20. So using this formula, my answers would be negative 20, and then add 2, negative 18. Those are consecutive even numbers, even though they're negative. Now let's find the other answer over there. Second calculator trace. Go to the other side and press up to go a little faster. Oh, that should be close enough. Enter, enter, enter. And you get 18. So again, based on the formula right here, x would equal 18 and add 2 to that, and that'd be 20. And they are consecutive even numbers, so it makes sense. So move on to the next one. Is it possible, oh that's a loaded question, to bend a 12 centimeters length of wire to form the perpendicular sides of a right angle triangle with the area of 20? Okay, so that's what they're talking about here. So perpendicular sides, that's this side, of a right angle triangle with the area of 20. So it just wants to know the perpendicular sides. So is it possible? So area equals 20. So if it's, is it possible? It's generally like a hint that's going to be the discriminant. Is the discriminant greater than 0? Is it equal to 0? Is it less than 0? Right? If it has solutions, if it has one solution, it'll be equal to 0. If it has two solutions, it'll be greater than 0. If it's not possible, it'll be less than 0. So let's look at, let's try to solve this. So two sides of we have a piece of wire here, and it's 12 in length. So here's the trick we do, right? Because we're going to make up these two sides right there. So what we do is what we always do: make one side x. That makes this side 12 minus x. That's a trick. You have a side of length 12. You just pick a random side, make it x, cut it. The other side must be 12 minus x. So if this is 3, this must be 9, type of thing. So one side is x, and one side is 12 minus x. And then we're talking about area of a triangle. Area of a triangle equals 1/2 base times height. So let's plug everything in. 20 should equal 1/2 x times 12 minus x. Then we just got to kind of solve it. So I get 6x minus 1/2 x squared equals 20. Let's move that over here. Move everything over to that side because I just don't like negative x squares. Plus 20 equals 0. So I have this. Now if I solve it, it does tell me what the answers are, but the question is it possible? So that's all they want, if it's possible. So we're just going to do the discriminant real quick and see if it's possible. Right, the discriminant is b squared minus 4ac. Here's my a, here's my b, here's my c. So we're just going to do the discriminant. Let's see, checks if it holds. So I'm going to have negative 6 squared minus 4 times 1/2 times 20. So it's 36 minus 2 times 20, 36 minus 40, so negative 4. You know what that means? If negative 4 means it has no solution, so it's not possible, right? If it's greater than 0, it has 2 solutions. If it's equal to 0, it has 1 solution, a double root. And if it's less than 0, it has no solutions. This is the discriminant's less than 0, so no solutions, so not possible. Okay, let's move on to optimization with quadratics. So optimization just means finding a maximum min value. And we know with quadratics, maximum value is just a vertex. So if they ever want you to find the maximum value of something, and it's a quadratic, you just gotta find the vertex. Now, just like before, we're gonna do this with our calculator, because I want to show you how you do this stuff with your calculator. So if we're doing the first one here, the general idea is basically don't forget you can use your calculator if it's a calculator portion of a test. You go, wait, oh, they want to find the max of this, and it's a parabola? Just graph it. Again, if it's a calculator portion. If it's not a calculator, you could just find the vertex using the techniques we talked about before. So x squared plus x minus 3. I'm going to put my window back to zoom standard. See how it goes, see if I can see the vertex. There it is right there. So if I'm trying to find the max, I just got to find second calculator. In this, I should say min. In this case, it's a minimum. It's opening up. And go a little left of the vertex, a little right of the vertex, and you get your minimum. Now again, the min in this case, since we're only looking for the minimum value, is actually the y. That's the lowest we go. So for this guy, it is y equals negative 3.25. And for my work, I'll just show the graph. I could do the same thing here, right? I'm just going to graph down real quick. 3 plus 3x minus 2x squared. Hit graph, I set on standard, and it's right there, and I just found the max. Second calculator max is number 4. Left bound is already left of it. Right bound, I'm going to go right of that vertex now. Hit enter, hit guess. And again, so y value is actual max, so y equals 4.125. And I'll probably just show a graph to show the work I'm doing. So that's kind of the idea for optimization. Let's do a slightly harder example. So in this one, a gardener has 40 meters of fencing to enclose a retaining garden plot, where one of the sides is an existing brick wall. Suppose two new equal sides are x meters long. So we have this brick wall here, so I don't need fencing on there. So they're saying the whole thing has 40 meters. So all this put together is 40. But we have two equal sides of x. And as we talked about before, if you want to figure out what this side is, you just go, okay, what's the total? 40. Subtract the 2x's. So this should be 40 minus 2x. Now look at part A. Show that. Very important word there for IB. When something says show that, you cannot just copy the answer. When show that area enclosed is given by this equation. So you gotta show something like this. Area equals length times width. You probably want to do on the side 40 minus x equals 40 minus 2x. So the area equals length, which in my case is 40 minus 2x, times width, which is x. So that's A. B is find the dimension of the garden's the max area. So let's actually do, I'm going to actually do it by hand for one of them. So for B, I want to find the max area. So let me simplify this. I get 40x minus 2x squared. Now if I was trying to find the vertex, x equals negative b over 2a. Your A is linked with the quadratic, so that's actually A, and this is B. And my C I don't have, which is 0. Just plug in the formula, I get negative 40 over 2 times negative 2. So I get negative 40 over negative 4, or just 10. So the dimensions of my x value to give me the max area, but I need like both sides. So x is 10, and that makes the, or I should say my width is 10, and that makes my length, what's that, 40 minus 2 times 10? So 40 minus 20, so just 20. So my dimensions are 10 by 20. Now if I were to plug this back into the equation, I would actually find the max value, or my max area. let's talk about quadratic inequalities. So we just talked about a little of this last time. Quadratic inequalities are just quadratic inequalities. When is the quadratic greater than 0 or any other number? Easiest way to do this is by using a sign diagram. So the best way to think about it is like, here's your graph. X-intercepts are like these little, you want to put little tempos, your x-intercepts. And then if it's above the x-axis, it's positive. If it's below it, it's negative. And if it's above it, it's positive. So that's how you get a sign diagram that's, oh, before -2 is plus, in between is negative, after 1 is positive. Over here, notice there's no x-intercepts, so I have no markings down here. It's all above the x-axis, right? Plus and minus. It's all on the above side. This one actually hits 0, so I actually do have a marking there. Because it's going to be like negative infinity to -1 union 1 to infinity. We stop for a split second where you're 0, so you're not positive or negative. 0 is neutral. But everything else is below. So let's look at one of these. Have you kind of noticed, by the way, before I move on, that if the power here is odd, we say it cuts through the x-intercept, so like x-axis, so you just go straight through it. But if the power is even, and you hit the x-intercept, you bounce off of it. So if I saw a graph that was like this, that's all there was. I'm like, oh, I know at 2 it bounces off of it. Compared to if I saw a graph that was like this, they're both singles, so I know they cross at 3, and they cross at -2. So first question, let's do a sign diagram for this. Right, so here's the best way to know it. Right here's at -3, we'll draw a line there. So if I was doing a sign diagram, we'll have it at -3. And then we have one at 5. And then look what happens to your graph, right? Before -3, I'm below, so minus. Between -3 and 5, I'm above the x-axis, so plus. And after 5, we're below the x-axis again, right? Here's my x-axis, so negative. So that's the sign diagram. Do the same thing over here. Right, now it does hit the x-axis, so I will put a mark in -1. But before it, it's all above the x-axis. And after it's all above the x-axis, so it's plus and plus. It's the sign diagram there. Now they want to draw a sign diagram for these guys. So easiest way is to just graph it. So how would I graph this? I would factor it. This is x plus 3, x minus 1. What do you do in your calculator and find the x-intercepts? But in this case, if I just graph it, my x-intercepts are -3 and 1. Now again, we're just trying to do a sketch to see if it's positive, negative. This graph right here, the A is 1, so it's opening up. So it'll kind of like this. Again, I don't care about anything else besides it's opening up. Now if I want to do a sign diagram, well, hits x-intercepts at -3 and 1, so those are my things here. Before -3, my graph's above the x-axis, so positive. Between it, it's below, so negative. And afterwards, it's above again. Right, it's above the x-axis. There's my sign chart. If I was doing this one, there's actually only one x-intercept, right? X equals 3. If I was going to like graph it, I would go, okay, you go to 3, nothing out here, and then it opens down. So I was doing a sign chart. At 3, I have my line. Anything before 3 is negative. Anything after 3 is also negative. Those are my sign charts. So how do we solve with the sign chart? Same idea. So let's do this one first. We'll set equal to 0. 3x squared plus 5x minus 2 is going to equal to 0. Then I could factor it. In this case, I'm actually just reminding you guys how to factor the number in front. I'll multiply the first term and last term. I get -6x squared Try to think of a combination that multiplies to get negative 6, but adds to get positive 5. In this case, that would be 6x and negative 1x. Multiply to get you negative 6, but when you add, you get 5x. And then I substitute it back in for the 5x. Alright, so I just substitute that back in there. These stay. Then you factor by grouping. These have a 3x in common. X plus 2. You always bring down the middle sign. Have an x. Remember, so when you factor divide, so negative 2 divided by negative 1 is actually a positive 2. And hey, these match. So you get x plus 2, 3x minus 1, is going to equal to 0. Then you solve like you normally would. Just split it. I would get x equals negative 2 and 3x. If I set that equal to 0, 1/3. So I look at a graph. I have negative 2, 1/3. I'll put 1/3 right there. Does it open up or down? Look what I have. Opens up. You always, if you do this, you always want a standard form. So you want the x's on the left hand side. And then I want to see where I'm greater than 0. So do a sign chart. Here's negative 2. Here's 1/3. Before negative 2, you're above the axis, so positive. You're below, so negative. Here to the right, so positive. Again, and so I want greater than 0, so I want all the positive ones. So my answers are negative infinity to negative 2. Union 1/3 to infinity. Right, anytime it goes down to the edge, it's always infinity. So there's the answer. Now if I was using a calculator, I could also just graph those 2 points, or those 2 equations. 3x squared plus 5x and then 2. Go to zoom standard. I think I have that already, but just have a check. The graph looks like this and like that. Right? The question is, when is 3x plus 5 greater than 2? Well, look at beforehand. The 3x plus 5 is greater than the 2, so it would have been negative infinity to negative 2. And you can figure out what to intersect by using your calculator. In the middle, the 2 is actually bigger than the parabola, so that's not it. And anything past here, the parabola is bigger than the line. So it would have been the exact same answer. So that's how you can do it in your calculator. If I was doing this one, it would have been the exact same thing. This one's a little easier because it actually factors. Well, it factors nicely. So I have that. That could factor. It's x minus 3, x minus 3. Or x minus 3 squared is less than 0. If I graph that, you go to 3. It's a positive x squared, so it opens up. I want to know when's it less than 0? Never. So no solution. Okay, one more problem and then we are done. Find the values of k for which the function cuts the x-axis twice, touches the x-axis, and misses the x-axis. So this is another discriminant question, right? Cuts the x-axis twice, that's when the discriminant is greater than 0. Touches the x-axis when we have one solution, discriminant equals 0. And misses it, discriminant is greater than, less than 0 I should say, sorry. And remember the discriminant, if you forgot, is b squared minus 4ac. It's everything underneath the square root of a quadratic function, a quadratic equation. Anyway, so in this case, it's already in standard form, so you just kind of what your a, b, and c are. My a is the thing next to my x squared, so that's a. This is my b, and this is my c. So literally, let's just find it. So my b is k plus 3 squared minus 4 times a, which is k, times c, which is negative 1. So right here, I just can't be lazy. It's k plus 3 times k plus 3. Should get you k squared plus 3k plus 3k. We should know it's k plus 6k already, plus 9. So k squared plus 6k plus 9. All of this, negative 4 times negative 1 is 4 times k is 4k, so plus 4k. Simplify a little bit, I get k squared plus 10k plus 9. It's a k not x. So what we're gonna do what we always do. Let's look at the graph of that guy. Let's see if I can factor it. Like let's rewrite it. So let's do the first one first. I want to find out k squared plus 10k plus 9 is greater than 0. We're actually lucky we actually just factor that. It's k plus 9, k plus 1. Alright, so if I graph that, cross that negative 9, cross that negative 1, it's opening up because it's a positive k. It looks like this. So right there, actually, I could answer everything. Right, when is the discriminant, this equation, greater than 0? Well, from here, right here, this side, not in the middle, that's when it's below, and on this side. So from negative infinity to negative 9, union negative 1 to infinity. When does it equal 0? So when does my equation equal 0? The x-intercepts, negative 9 and negative 1. And when is it less than 0? When the graph is below the x-axis, so in the middle right here, from negative 9 to negative 1. And that's the idea.